Here's a typical airspace visualization, the kind you'd never see as a passenger, but one that's constantly alive above us. Hundreds of aircraft are zipping through the sky, climbing, descending, banking through invisible corridors, all flying at over 500 knots. Every single one has a destination, a flight plan, a clearance, and a purpose. It's like a massive, invisible orchestra of motion, happening miles above the ground. It's like watching a three-dimensional highway, with no lanes and no visible rules, yet somehow, everything flows. At first glance, it looks like chaos. It looks like a sky full of accidents just waiting to happen. Now freeze the frame right here. See those two planes? They're on a direct collision course. How can we prevent this with a sky full of airplanes? What can we do so this never happens? Let's find out more about the key safety systems in play. Enter air traffic control. Controllers monitor radar scopes that show every aircraft's altitude, position, and flight path. Their job? Spot potential conflicts before they happen and issue instructions to prevent them. They give pilots headings, altitude changes, speed restrictions, whatever it takes to maintain safe separation. In busy terminal areas, it's a constant puzzle. Sequencing arrivals, vectoring departures, avoiding weather, all while keeping aircraft from getting too close. But controllers are human, and even with backup systems and radar, things can change fast. When traffic gets dense and instructions start piling up, even the most experienced controllers can be overwhelmed. Fatigue, radio congestion, last-minute route changes, they all increase the workload. A delayed call, a misunderstood instruction, or a momentary lapse in attention can create a chain reaction. In the high-speed environment of controlled airspace, even a few seconds of confusion can bring two aircraft dangerously close. That's why relying on human vigilance alone isn't enough. Something more is needed. Something automatic, independent, and always alert. Every aircraft has a transponder, a small device that responds to radar by broadcasting the plane's altitude, position, and unique code. When ground radar pings the aircraft, the transponder sends back a reply almost instantly. This information helps air traffic controllers identify and track each aircraft with precision. There are different modes, like Mode C for altitude reporting and Mode S, which allows for more detailed data exchange between aircraft and ground systems. Transponders also broadcast their signals continuously, even without a radar ping. And that's exactly what another critical system on board listens for: TCAS. So, what is TCAS? It's a safety system built into modern aircraft that helps prevent mid-air collisions. Using signals from other planes' transponders, TCAS constantly monitors the sky for potential conflicts. It doesn't rely on air traffic control. It's fully automated and always watching. TCAS uses two types of antennas, one on top of the aircraft and one on the bottom. These antennas continuously send out interrogation signals, kind of like radar pings, to detect other aircraft nearby. When another plane's transponder receives the signal, it replies with its altitude and position. By measuring the time and strength of these replies from different angles, TCAS can calculate the other aircraft's distance, direction, and whether it's climbing or descending. This gives the system a real-time 3D view of surrounding traffic, above, below, and all around the aircraft. In high-altitude airspace, aircraft follow RVSM, Reduced Vertical Separation Minimum. Instead of being 2,000 feet apart, planes flying between flight level 290 and flight level 410 are separated by just 1,000 feet vertically. That's safe as long as everyone stays at their assigned altitude. But now imagine this. Two jets are cruising directly toward each other offset by 1,000 feet. Suddenly, one aircraft begins to climb just 500 feet. Now the vertical separation is cut in half. Too close. As the aircraft closes in, TCAS begins tracking the threat. 40 seconds before impact, it issues a traffic advisory, or TA. A loud voice warns the pilots.
Traffic, traffic.
This alerts the crew to look outside and prepare for possible action. Then, at about 25 to 30 seconds before collision, TCAS escalates. It issues a resolution advisory, or RA, a direct, audible command like,
Climb, climb now.
Each aircraft gets complementary instructions, ensuring one climbs while the other descends. The system continuously monitors both planes and updates its commands in real time. If needed, it can issue reversals or strengthen the maneuver. And if both pilots follow the TCAS instructions exactly, the aircraft will miss, with vertical separation restored, often by just a few hundred feet.